PurposefulNudge introduces a pathway to reduce process debt and cognitive load based on the framework in Field Services Rewired.
We see companies pouring millions into artificial intelligence, expecting smooth operations. But down on the front line, technicians rely on sticky notes and group texts. Why? Because most organizations aren't actually transforming how work gets done. They are just taking their tangled, outdated processes and automating them. To actually get your team to adopt new technology, you have to design the workflow so that doing the right thing is the easiest possible action for a worker to take. Step by step, we are going to look at the Field Services Rewired method. This is a blueprint to help you strip away that accumulated process debt and build intelligent, frictionless operations. If you apply an advanced AI to a broken workflow, you don't solve the inefficiency. You execute a bad process at a much faster speed. Step 1 starts before you configure a single piece of software. Leaders have to establish clear operational standards. These act as strict guardrails for both your frontline workers and your AI algorithms. Setting these standards changes the objective for the technician. The goal shifts from trying to fix a broken machine as fast as possible to the higher purpose of safely restoring production. Every job has to stand on this foundation. There are 3 structural pillars. The technician must confirm safety, validate the root cause, and capture the data exactly once. An AI system can certainly accelerate how quickly a worker moves through a task, but as you can see here, the technology is never allowed to route around these core requirements. By defining these rules up front, you protect human judgment. You ensure that safety and accuracy are never overwritten by an algorithm optimized solely for speed. Step 2 requires stepping out of the conference room. You need to conduct a day-in-the-life observation, or DELO. This means going into the field to map how work actually happens under pressure, rather than relying on what the standard operating procedure says. Look at this comparison. On the left is the official 14-step linear workflow. On the right is reality. Technicians frequently abandon the official tools because they are too slow, and instead call a senior peer or check a group chat to get the answer. These markers represent friction sparks. These are the exact moments where the official system fails the user in a real-world environment, forcing them to improvise. These friction points are your most valuable data. They show you the exact locations of the process debt that has piled up in your legacy systems over the years. Mapping the ground truth shows you where the front line has already lost trust in your tools. If you drop an AI model blindly onto a step that technicians already bypass, that deployment will fail. Now that we see the process debt, step 3 is removing it. We push the real-world workflow through this industrial 4-step filter, stripping away the friction before we turn on any AI engine. This sieve runs on 4 distinct rules. You eliminate unnecessary approvals, automate the manual tasks, collapse redundant forms together, and proactively guide the technician to the next best action. Practically, this means taking a tedious 10-field manual check-in form and collapsing it down. A worker snaps one photo of an equipment nameplate, and the system automatically extracts all the required serial numbers and model data. This brings us to the cardinal rule of field operations. You must never digitize a bad process. By purging the process debt first, you guarantee that your AI is accelerating a lean, highly effective operation rather than amplifying a bloated one. Step 4 focuses on the moment of work. This is that narrow, high-pressure window where a technician is standing in front of broken equipment, surrounded by noise, and has to make an immediate decision. If your digital tool forces that worker to navigate complex menus or read a dense 20-page manual while on a ladder, you add cognitive load. High cognitive load under pressure destroys any chance of technology adoption. To fix this, you use AI nudges. Notice how this interface reacts. It strips away the noise, replacing complex instructions with a single, highly visible command exactly when the environmental pressure spikes. When a system introduces ambiguity during a crisis, humans will always drop the tool and revert to familiar, unofficial workarounds to survive. Step 5 addresses the long game. Sustained AI adoption does not happen just because you rolled out new software. You have to engineer a psychological contract with your team, known as the trust loop. Let's follow this flowchart. It starts when the AI provides grounded, specific guidance. Then, the human technician physically validates that recommendation against real-world conditions. Once that validated action leads to a successful repair, the technician's confidence in the system goes up. Every time the tool proves reliable, the loop strengthens. Trust is earned exclusively through repeated reliability in the field. Without the trust loop reinforcing that relationship, even the most expensive AI models will be quickly abandoned by your workforce. Success on a single machine repair provides a validated template. By solving for the specific friction points of one job, you create a repeatable model that can be applied to other complex workflows. Scaling then becomes a matter of deploying these rewired workflows to other sites. When teams across different regions use the same simplified, trust-backed systems, the performance of the entire field force begins to stabilize. This transition produces measurable improvements in output. Companies following this model see first-time fix rates climb toward 88% and a corresponding drop in the cost of repeat dispatches. Rewiring field services is ultimately about designing your systems for the human moment of work. It is not about deploying the most software licenses. Stop automating your process debt. Start building systems where the right operational behavior is the easiest behavior for your technicians to execute.